Welcome to day 4, linear and nonlinear relations. So I'm going to be running through this lesson with you this morning. You can follow along on the handout provided by your teacher, and we'll do our best to get through it as painlessly as possible. Check out the cheesy math joke. If you don't get it, that is okay. So let's begin. So here is 2 graphs, and I know they're going to be hard for you to see on your handout. Basically, this graph on the left here just shows the development of a baby boy for the first 3 years. So the x-axis along the bottom, and it's sort of broken up. So this is birth, 3 years, 6 years, 9 years, 12 years, and so on. This first graph, the bottom graph, shows their weight development. So for example, at 3 years, they should be between 5 kilograms and 7.3 kilograms would be normal development for a boy. So you're probably going to see this if you have a child, just to see that your baby is growing normally. Anyways, for each, the boy and the girl graph, part of it looks to be linear and the rest of it looks to be non-linear. So if you notice, the first, probably not 3 years, but I'd say, because right when it gets to 3, it looks like it's already starting to curve. Definitely for the length, right? At this point, you can see a curve at it for both the boy and the girl graph. So I'd say maybe the first, 2 years, even 1 year, 1 or 2 years, should be linear. Basically, they're growing steadily for that first 12 months. Everything is growing linearly, right? So to about, somewhere in here, right? You can see that looks pretty straight up to that red line, as well as, if that was better, sort of a crooked line. But anyways, you can see it's linear up to that point for both the girl and the boy graph, right? Looks to be linear up to that point, or thereabout. So for what age range does the growth appear to be linear? You could say, maybe I'll type this. Between birth and 2 years old. Okay, and then for what age range does it appear to be nonlinear? You could say age growth is nonlinear. After 2 years of age, it looks like the development is nonlinear. It's curved, right? From this point to 36 months or 3 years. Oh, I think I'm reading the scale wrong here. I think this is in months. So birth to 2 months. My apologies. This should say 2 months. Birth to 2 months old and after 2 months old. I guess I should read the units on the scale. Because clearly we're not measuring growth to 36 years old. Yeah, so up to about 2 months, it's linear, and after 2 months, it looks to be curved. Sorry about that. I was about to ask if there was any questions, but clearly I can't answer your questions. All right, let's move on to the next thing. So for linear relations, we can see that we can put on a line of best fit. We looked at that last class, but for ones that are nonlinear, we can do something called a curve of best fit. And the principles that we need to follow when doing a curve of best fit look pretty much the same as a line of best fit. The first one is that you need to follow the general trend of the data. So your curve should follow the points on a scatter plot, obviously. You don't want to have your curve going in the opposite direction. Second thing is that the curve should pass through as many points as possible, and it needs to be smooth. So you can't have any jagged edges on your curve or to change directions really quickly. It needs to be a smooth curve. And the third thing is that just like the line of best fit, you're going to aim to divide the rest of the points that you can't go through above and below, right? So go through as many points as you can with the curve, and then whatever's left should be split above and below your curve, right? So all these things basically are just like a line of best fit. So all the same principles apply. It's just going to be a curve instead. So let's look at our first example. So here is a table of values, gives us a bunch of x and y values in a graph. We're asked to plot it and show if it's linear, draw a line of best fit, and if it's non-linear, draw a curve. So you can follow along and put the points on. I'll do that here as well. -4, -3. Alright, so this one looks to be relatively linear. If you follow a general trend of points, they look to be in a straight line, even though some are horizontally beside one another. You could probably model this pretty well by drawing a line right through. I don't have a line tool here, so I'll try to freehand it with my mouse as best I can. Put arrows on the end. So if that was straight, I'd be going through 6 points, and then there would be 1, 2 above my line and 2 below my line. So that's about the best I can do, right? I'm going through as many points as I can, and I'm splitting exactly above and below. So that's what we're looking for. This one was linear. All right, let's do example 2. So again, let's plot the points. All right, so this one appears to be non-linear, I would say. The points don't go in a straight line here. For future reference, this is in grade 10 you'll study this. This is called a quadratic. Looks like I'm going to have to make a part 2 of this video, so join me in part 2 and we will finish the lesson together.